Hello everyone, how are you all? I hope that all of you are doing amazingly great. First of all, welcome to this session. So we are on session 2 of basic mathematics. What are we going to do in today's session? We are going to be learning about inequalities, and in inequality there's a very important method which is known as wavy curve method, which is very important because it is used in JEE examination. Basically you can't crack JEE examination without knowing this method. It is that much important. You can't crack the examination without knowing this wavy curve method to deal with inequalities, because inequality is used in every other chapter. This is the basic of mathematics. It will be used in every other chapters. Whether it is inverse trigonometric function, determinants, matrices, it can be used anywhere or everywhere. Conic sections, it can be used everywhere. Right? So wherever inequality comes, wavy curve method comes. Okay. So we'll be learning about wavy curve method in today's session. My approach will be little bit logical in understanding the wavy curve method. What I want you to understand, basically I want you to understand the method. It's not just about, following the steps. We will follow the steps. I will give you the proper steps, that this is how you apply wavy curve method. It's not baby curve method. Okay, it's a wavy curve method. Okay, so I will give you proper steps to apply. Okay, but more than that, it is very important to understand why does these steps work, why are we following these steps. So to understand that, so that is much more interesting, okay, to see, to understand. Okay, we are going to start from very basic. Okay, so as I told you, let's get started. Inequalities. So we have seen many kinds of inequalities. So these symbols, first of all, as I told you, we'll start from very basic. All of you know what does the symbol means? Yes, this symbol means equality. It means this is equal to some other, right? Just say A times B plus C is equal to AB plus AC. These two things are equal to each other, so we are using equality, right? This symbol is greater than symbol. This symbol is greater than symbol. Okay. Like suppose we have 2 raised to the power 5 and 5 square. So we will be applying greater than symbol, that 2 raised to the power 5 is greater than 5 square. Yes, because the value for 2 raised to the power 5 is 32. Here the left hand side is 32. 5 square is 25. So obviously we know that 32 is greater than 25. Okay, so this is a greater than symbol. Okay, now we have a symbol less than symbol. Okay. If we talk about -8 or -3, we will be using less than symbol. That -8 is less than -3. -8 is less than -3. Then we have greater than or equal to symbol. Greater than or equal to symbol. See, what do we mean by or? So we basically use this symbol if this side is greater than or equal to the left hand side, right? So here, like a square is greater than or equal to 0. The square of any real number, okay, where a is any real number, square of any real number is greater than or equal to 0. Basically it means that it can be equal to 0 or it will be greater than 0, right? Like suppose I can use this symbol over here. 5 greater than or equal to 5. Yes, this works. This is definitely true. 5 greater than or equal to 5. 6 greater than or equal to 5. That also works. 6 greater than or equal to 5. That also works. You must be like, sir, 6 is not equal to 5. So why are we using greater than or equal to? Yes, we can use that. Greater than or equal to. It means greater than or equal to. So if it is greater, 6 is greater than 5. Yes, it works. 6 greater than 5, this is also true. 6 greater than or equal to 5, this is also true. Both these statements are true. You can't say that the first statement is wrong. First statement is not wrong. The meaning of symbol is or. Or in Hindi means yeah, either or. Greater or equal. So it is greater. We can definitely see that 6 is greater than 5. So yes, this symbol works over here. Then we have the symbol of less than or equal to. You know where to we use this symbol. Suppose there is -8, -3. Okay. So -8 is, yes, we can write less than or equal to -3. -8 is less than or equal to -3, or -8 is less than -3. Both these symbols work. Okay. Now let's move ahead. So linear inequality in one variable. There is a variable x, x plus 1 greater than 2. Can we solve this inequality? Yes, easily. We can simply send this plus 1 to the right hand side. Okay, plus 1 to the right hand side. So we have x greater than 1. 2 greater than or equal to 5 minus x, ax plus b less than or equal to c. So we can use these, we can solve these linear inequality very easily. So this is linear inequality in one variable. And here we have linear inequality in two variable. Here the variable are x and y. Okay, variables are x and y. So in today's session, we'll be dealing with only linear inequality in one variable, like linear inequality entirely in terms of x. We deal with linear inequality in two variables by, plotting the straight line. So we'll deal with this later. There's a chapter called linear inequality in two variables. There we'll be learning about this thing. In today's session, we are only going to be learning about linear inequality in one variable. So there are some basic rules which we need to know. So the first basic rules is that if it is given that a is greater than b, everyone, a is greater than b. If I add a constant or subtract a constant on both the sides, there will be no change in the inequality. Okay. So if I add a constant like c, so if I add c on both sides, or if I subtract c on both sides, there will be no change in the inequality. Inequality does not change. Suppose we know that 5 greater than 3. If I add any number to both sides, if I add any number to both sides, this will not affect the inequality. Inequality still follows, right? It is still true. 5 plus c is greater than 3 plus c, or 5 minus c is greater than 3 minus c. This is still true. There will be no change in the inequality if you add or subtract a constant. Okay. But if you multiply by a constant, then there might be a change in the inequality depending upon what is the sign of that multiplication, right? Suppose a greater than b is given. If I'm multiplying by c on both sides, and if c is a positive number, then there is no change. But if c is a negative number, the inequality will change. Basically, if you multiply by a negative number, the inequality reverses. If you multiply by a negative number, suppose 5 greater than 3, everybody knows this. If I multiply by 2 on both sides, there will be no change. If I multiply by 2, 10 and 6, and of course the same thing will follow, right? But if I multiply by a negative number, suppose I multiply by minus 1 on both sides, then of course the inequality, of course it is going to change, right? If I multiply by minus 1 on the both sides, the inequality will change. If I suppose multiply by minus 2, basically any negative number. If I multiply by any negative number, then only the inequality changes. Okay. Adding or subtracting a constant does not affect the inequality, but multiplying by a number or dividing by a negative number. Okay, you can write that down. Note that down. Multiplying or dividing by a negative number changes the inequality. For an example, here we have minus 2x greater than 1. Suppose it is written minus 2x greater than 1. Okay, or let's say minus 2x plus 5 greater than 4. Okay, suppose this is the question. Minus 2x plus 5 greater than 4, we want to solve for x basically. Okay, so how do we solve this? If I take this plus 5 to the right hand side, this plus 5 will become minus 5. Will there be any change in the inequality? Of course not. The inequality will not change over here. Basically, you are subtracting 5 from both sides, right? From the left hand side, you are subtracting 5. From the right hand side also, you are subtracting 5. That's all you are doing. So we have minus 2x greater than 4 minus 5. Do you understand this? Basically, from this to this, we have subtracted 5 from the both side. Here we have 5 in the addition. If I send it to the right hand side, it will become, plus 5 will become minus 5. Okay. So we are just subtracting 4 minus 5. There will be no change in the inequality. Inequality will not change over here. Okay. Now we have minus 2x greater than minus 1. Now I am looking for what is the value for x. What can we say about x? Okay. So minus 2 is in the multiplication of x. If I want to send it to the right hand side, it will go in the division, right? Here it is in the multiplication. If it goes to the right hand side, it will get divided. Okay, so basically I'm dividing by a negative number. Correct? What I'm doing over here, if I send -2 to the right hand side, basically I am dividing by a negative number. So will it affect the inequality? Of course, because it is a negative number and I'm dividing by a negative number, it will definitely going to affect this inequality. So x will be, see, the inequality changes. Inequalities changes. In the right hand side we have -1, we are dividing it by -2. So x is less than -1 by -2. So basically x is less than 1 by 2. That's the answer. Okay. So these are some basic rules about inequality. So if you multiply by a positive number, the inequality does not change. But if you multiply by a negative number, the inequality reverses. Okay. Clear? Now, if you do the reciprocal, a greater than b implies 1 by a is less than 1 by b if the product of ab, basically a and b should be of the same sign. If you do the reciprocal, then also inequality changes, provided that both these sides are of the same sign. See, ab greater than 0. What do we mean by ab greater than 0? It means that either a or b both should be positive or both should be negative. Okay, this means that a and b should be of same sign. Okay, that's all. AB greater than 0. If both of them are positive, yes, it is greater than 0. If a and b both are negative, then also it is greater than 0. So basically the rule is that if it is given that a greater than b, if I want to do the reciprocal, then inequality will change. 1 by a will be less than 1 by b. Let me give you an example. Okay. Let me give you an example. Very easy. Okay. What do we say about 5 and 3? Which one is greater? Everybody knows. Yeah, this is the symbol, 5 greater than 3. What will happen if I do the reciprocal on both sides? What will happen in that case? So 5 will become 1 by 5. 3 will become 1 by 3. Now, will you use the same inequality or will you change the inequality? That's my question. Is 1 by 5 greater than 1 by 3 or 1 by 5 less than 1 by 3? You tell me. So of course, 1 by 3 is greater. 1 by 3 is 0.33 something. 1 by 5 is 0.2. So 1 by 3 is of course greater than 1 by 5. So if you are doing the reciprocal, the inequality will change. Okay, this is example 1. Okay, let me take few example. This is example 1. Everybody understands this example? Let me take second example. Okay, suppose both the numbers are negative. -5, -3. What will you say for now? For now you will say that yes sir, -3 is greater. -3 is greater than -5. If you do the reciprocal, there will be -1 by 5 in the left hand side, there will be -1 by 3 in the right hand side. Will the inequality change or not? Will the inequality change or not? Is -1 by 5 greater or -1 by 3 greater? -1 by 5 is -0.2. This is -0.33. Basically this is -0.2. And this is -0.33. Which one is greater? Which one is greater? Of course, -0.2 is greater than -0.33. So yes, inequality should change. So inequality is changing. So inequality will change. This is the rule of reciprocal. If I want to do the reciprocal, this is the rule. This is the rule of reciprocal, that inequality changes. But only if both these sides are of the same sign. Here see, both these sides are of the same sign. Then it happens. It does not happen if both the, see, this rule does not work. This rule does not work. Okay, I don't want to go into much detail over here and confuse you guys, because see, it's very important to understand that this reciprocal rule does not work if both the sides are of different sign. Suppose if we talk about 5 and minus, 5 and -3. If we talk about 5 and -3. Okay. So currently we know that 5 is greater than minus 3. If we do the reciprocal, 1 by 5, and here we have minus 1 by 3. Basically, why does it not work when the numbers are of different sign? There's a 0 in between them. That's the problem. There is 0 in between them. Okay, we can't do the reciprocal of 0. Inequality, see, from minus 3 to 5, there will be 0 in between them. We can't do the reciprocal of 0. So if we want to do the reciprocal, we have to break it at 0. Then only we can do the reciprocal over here. Okay, so 1 by 5, see, inequality does not change. Inequality is not changing over here. Okay, but it's not necessary that every time the inequality will not change. Okay, so there's the thing, everyone. So this rule works when both these sides are of the same sign. That's it. Okay, for now, this is all you have to understand. This is the rule of reciprocal. Now, let's solve few questions. 2x minus 6 greater than 0. Can you solve this inequality? Very easily. In the first part, you will send this minus 6 to the right hand side. It will become plus 6. Minus 6 goes to the right hand side. It becomes plus 6. Dividing by 2, x will be greater than 6 by 2. X is greater than 3. This is the answer for the first part. Okay. In the similar way, second part is also very easy. 3x is less than 12. See, minus 12, you are sending it to the right hand side. Inequality is not changing now. Inequality is less than only. We are using the less than only inequality over here. So x is less than 12 by 3, which is 4. Yes. Very easy peasy. Okay, let's move ahead. 4x minus 10 less than or equal to 9. So in the first part, 4x is less than or equal to 10. If you send this minus 10 to the right hand side, 4x less than or equal to 10. X will be less than or equal to 10 by 4. So basically what is 10 by 4? It is 5 by 2. X is less than or equal to 5 by 2. Very easy. Second part, we have minus 9x. I am sending this minus 19 to the right hand side. Minus 19 will become plus 19. And same inequality, greater than or equal to inequality. There will be no change in the inequality, right? Now if I divide by minus 9, there will be a change in the inequality. So x is less than or equal to minus 19 by 9. That's our answer for this question. If I divide by a negative number, there is a change in the inequality. Okay, like in this question, the first part, guys, please try all of these questions by yourself. These are very basic questions. Just I'm doing over here so that if you have any little bit doubt, if you are, low in confident about inequality, you gain confidence in that. Okay, before moving to the Wavy curve method. Okay, so 5x by 2 is less than minus 9 by 7. 5x by 2 less than minus 9 by 7. What can you say about x? So simply multiply, basically divide by 5 by 2 or multiply by 2 by 5 on both the sides. So x is less than minus 9 by 7 multiplied by 2 by 5. Basically you are dividing by 5 by 2, right? Dividing by 5 by 2 or multiplying by 2 by 5, whatever you can say. There will be no change in the inequality because you are dividing by a positive number. In the right hand side there is a negative number, but you are sending a positive number, no? You are dividing by a positive number. So there will be no change in the inequality. Okay, so here we have x less than minus 18 by 35. Okay, very easy. Now the second part, the B part for this question, we have 3x greater than or equal to, if you send this 8 to the right hand side, 23 minus 8, that will be 15. So x is greater than or equal to 15 by 3, dividing by 3, x greater than or equal to 5. That's our answer. Now, let's talk about the next thing, which is intervals. Okay, generally, see, x less than 1. We use this notation. What do you understand by this notation? You understand by this notation that there is a variable x which is less than 1. That's it. There is a variable x which is basically less than 1. It can be 0.9, it can be 0.5, it can be 0, it can be negative numbers. Basically, this variable x can take several values. There is an entire interval, right? On the number line, you can see it in this way. That on the number line, there is a 1 over here. And in the left of 1, x is a variable in the left of 1. But it is not equal to 1. That part I hope you understand, that x is not equal to 1. It is less than 1. So this is how we represent it on the number line. Okay, it's very important for you to understand how do we represent it on the number line. So there's a hollow circle on the 1. This hollow circle means that we are not including 1. There's a hollow circle. I know you want to see this part right behind me, what is written. Okay, I'll show that part to you. But okay, for now just ignore it. For now we are just understanding the representation of, you know, these interval. X less than 1, how do we represent it? There's a hollow circle on 1, and in the left of 1 we are going. X can be any negative number, X can be -3, -4, minus infinity, right? It can go to the left, right? To the left of 1. This is how we represent it. Now, X greater than 1, how do we represent this one? So there's a 1 on the number line, and in the right of 1. Again, there's a hollow circle on 1. This hollow circle means that we are not including 1 in it. X is not equal to 1. See the third one, X less than or equal to 1. Now we can include 1 also. We have an equality. X can be equal to 1 as well. X is less than or equal to 1. So less than or equal to 1, here we have a filled circle on 1. This is how we represent it. Can you see the difference between the first photo and the third photo? The first one is saying X less than 1. This is saying X less than or equal to 1. Okay. And then in the fourth one, we have X greater than or equal to 1. This is how we represent it. So this is representation on the real number line. Now, there's a different way to represent all of this thing in the interval format. Okay. Like X less than 1, in the interval format, we represent it as X belongs to. This symbol is the belongs to symbol. Minus infinity to 1. See, you can imagine it on the number line. That X is basically a number from minus infinity till 1. X is a number in this interval from minus infinity till 1. Now, these brackets are known as open brackets. These brackets are known as open brackets, and this bracket is known as close bracket. Okay, you can see this bracket. This is known as close bracket. This is open over here. Here we have open both. Here we have open, and here we have close on one. Basically, where do we use close bracket? We use close bracket when we want to include that number. Okay, suppose I want to include 1. In the third part, I want to include 1 also. X less than or equal to 1. So I am using close bracket over here. In the first part, I don't want to include 1. So there is an open bracket. Okay. With infinity minus infinity, we always use open bracket, because we can never include infinity. Infinity is not an exact number. It is just an idea that X can go as low as possible. That's what we mean by minus infinity. That X is less than 1. So we are going in the left of 1, and we are not stopping till minus infinity. So X can be any, like, very large, very small number. Okay. That's the thing. So we use open bracket with minus infinity or plus infinity. That's the rule. X greater than 1, we can express it like this. X belongs to open bracket 1 to infinity. X less than or equal to 1, we are going to express it as minus infinity to 1 close bracket on 1, because we have equality over here. Okay. X greater than or equal to 1. Greater than or equal to 1 means in the right of 1. In the right of 1. So X belongs to close bracket 1 to open bracket infinity. Basically, till now you have understand that there are 4 types of brackets. There can be open bracket on both the sides. Okay. There can be open and close. There can be close and open. There can be close and close. Okay. These are the 4 types of bracket we have. Basically, if I say that X belongs to open bracket 3 to open bracket 5. Okay, always there will be a smaller number, then there will be a greater number. It can never be like this. It can never be like this. 5, 3. That's totally wrong. This is not the representation. There should be a smaller, then there is a bigger number over here in the right. So if I say that X belongs to, okay, again, this symbol is belongs to symbol. So if I say X belongs to open bracket 3 to open bracket 5, what does it mean? It means that X is greater than 3 and less than 5. This is what it means. If I say that x belongs to open bracket 3 to close bracket 5, so it means that x is greater than 3 and less than or equal to 5. There is a equality. Close bracket means equality. Close bracket means equality. Okay. If I say x belongs to close bracket 3 to open bracket 5, so it means that x is greater than or equal to 3 and less than 5. If it is written x belongs to close bracket 3 to close bracket 5, it means there is equality on both these sides. X greater than or equal to 3, less than or equal to 5. Okay. But with infinity and minus infinity, we can never use close bracket. We use close bracket with real numbers, not with infinity or minus infinity. Okay. You will never see close bracket being used. Suppose it is written that 5 to infinity. It means greater than or equal to 5, less than infinity. It is never like this, that there is a close bracket on infinity. It is never like that. Okay, you will never see that. Okay, now this is the notation of intervals. Let's discuss few more examples. See, x belongs to minus 2 to 1. It means that x is greater than minus 2, less than 1. You can see it on the number line like this. Okay, there is a hollow circle on minus 2 and 1, right? Because there's an open bracket. X greater than minus 2, less than or equal to 1. So x belongs to minus 2 to close bracket 1. Okay, this is how we represent it on the real number line. Very easy. X greater than or equal to minus 2, less than 1. So there's a close bracket with minus 2 and open bracket with 1. You can see it on the number line as well. There's a filled circle and there's a hollow circle. Filled circle with minus 2, hollow circle with 1. See, we are including minus 2. If we are including minus 2, there will be a filled circle. If we are not including 1, there is a hollow circle on it. Okay. X greater than or equal to minus 2, less than or equal to 1, there is a, close bracket at both the ends. Simple. Okay. Now solve this. 5 minus 2x greater than 13. Let's solve this one. So if I send this plus 5 to the right hand side, that works. Or you can send this minus 2x to the right and 13 to the left, that also works. But if you are, adding or subtracting a number, there will be no change in the inequality. Inequality only changes when you divide by a negative number or multiply by a negative number. We are not multiplying or anything in the first steps, right? So what I'm doing over here, I'm sending this 5 to the right hand side. So we have minus 2x greater than 13 minus 5. Okay. Plus 5 will go to the right and it will become minus 5. We have only minus 2x term in the left hand side, right? We have minus 2x term in the left hand side, plus 5 goes to the right, it will become minus 5. So 13 minus 5, that will be equal to 8. So minus 2x greater than 8, x will be, and now we are dividing by minus 2, so inequality will change. X will be less than 8 upon minus 2. X will be less than 8 upon minus 2. Basically, x will be less than minus 4. I hope you got the same answer. I hope you tried. Okay? Option C is the right answer. Let's move ahead. Now, find the solution of the following inequality and write in the interval format. So, the first one, okay. Let me do the first one for all of you. So the first one says that 3 times 2 minus x. So simply multiply 3 inside. Okay. So we have 6 minus 3x greater than or equal to x by 5 plus 4. So in the right hand side I am taking LCM. So we have x plus 20 divided by 5, whole divided by 5. X by 5 plus 4, I am taking an LCM over here. Okay, if you want to do the LCM, that works. If you don't want to do the LCM, that also works. Okay, no problem in that as well. Basically, solve it by your own way. The final answer should be same. That's the only thing. So if I take LCM by 5, we get x plus 20 whole divided by 5. Now I am multiplying this 5 to the left hand side. So there will be no change in the inequality. Inequality is still the same. 5 gets multiplied to the left, it becomes 5 6 are 30 minus 15x greater than or equal to x plus 20. Okay. Now, send this minus 15x to the right. So, minus 15x will become plus 15x, right? And there is already one x in the right hand side. And I am bringing this 20 to the left. So, plus 20 will become minus 20 when it will come to left. So, it will become 30 minus 20. right? Now 15x plus x will be get added up. There will be no change in the inequality because still I'm not dividing by any negative number. So 30 minus 10, we have 10 in the left hand side. It is greater than or equal to 15x plus x, which is 16x. Okay. So if you divide by 16, so 10 by 16 is greater than or equal to x. Or we can say that x is less than or equal to 10 by 16, which is basically 5 by 8. So x is less than or equal to 5 by 8. How will you represent it on the number line? On the number line, there is some number 5 by 8 over here. Okay, there is some number 5 by 8. Our number x is less than or equal to that. Basically, our number will be in the left of 5 by 8. Okay, so less than or equal to this. This is how you will represent it on the number line, which you can write in the interval format as x belongs to which bracket are we going to use? So there is a equality over here. So with 5 by 8, I will be using close bracket. Okay. So x belongs to minus infinity to close bracket 5 by 8. X is in the left of 5 by 8. So x belongs to minus infinity. See, there is no lower limit, right? X is greater than minus infinity, less than 5 by 8. So this is how I represent this in the interval format. I hope you understood the interval format. In the similar way, you can solve the second one. The second one I am giving to you as a homework. Try this. Simply take the LCM and just do the cross multiplication and follow the rules properly. That's all you need. Okay. Now, here we go. Okay. This is Wavy curve method. Wavy curve method, we are starting it right now. Very important method. Generally, we use this method whenever we are interested about product of things. Like here we have product of two things. Do you get it? X minus 1, x minus 4. There are two factors, product of two factors. So when we are talking about product of two variables, product of two factors, right? Both of these factors are in terms of x. Basically, still we are solving linear inequality in terms of one variable. There's only one variable x, right? In this entire picture, there is no y, only x. Not that x I'm talking about, this x I'm talking about. Okay, there's only x over here. So only one variable, right? So basically, we are multiplying two factors over here. So whenever there is a multiplication of factors, whenever there is like multiplication of two or more factors, or a division of two or more factors, suppose we have that. Like here we can have x minus 2, 5x minus 3, 4x minus 9, right? Different factors. Here we have x, here we have 4x plus 1. So suppose we have different factors and there's a multiplication. And if we want to comment about their sign, sign means that whether they are greater than 0 or they are less than 0. Where do we use Wavy curve method? Basically, that's what I'm telling you about. So we use Wavy curve method whenever there are products or a division of factors and we want to comment about their sign. That whether its sign is positive or its sign is negative. Whether it is greater than or equal to 0 or less than or equal to 0 or greater than 0 or less than 0. So basically 0 has to be there on one of the side. Okay. So there we use Wavy curve method. Here see, we have two factors and their product less than 0. Basically we are commenting about whether the product of these two factors is going to be negative or what. For what values of x, the product of these two things will be negative. The second question is asking that for what value of x, the product of these two factors will be positive. So Wavy curve method is used to comment whether the product will be positive or negative, where the product will be positive, where the product will be negative. That's what Wavy curve method tells us. Okay, we will get to these type of complicated questions, but these are also very easy. First of all, let's start with basic with these two examples. Let's start with that. So the first example, x minus 1 into x minus 4. There are two factors, right? One of the factor is x minus 1, another factor is x minus 4. Okay, less than 0. We want to solve this. Basically, we are looking for those values of x where the product of these two factors is less than 0. Less than 0 means negative, where the product will be negative. So how do we get started with that? First of all, just observation. Put any value of x. For x is equal to 4, what will be the product? For x is equal to 4, you can see that the product will be 0 only, right? If you put x as 4, this bracket becomes 0. 0 into any other thing, right? When you put x is equal to 4, this will become 3. 3 into 0 will be 0. So at x is equal to 4, it becomes 0. Similarly, you can observe that at x is equal to 1, this will become 0, right? What about x is equal to 5? At x is equal to 5, 5 minus 4 is 1, 5 minus 1 is, right? So at x is equal to 5, the product is looking as positive. What about x is equal to 2? At x is equal to 2, we have 2 minus 1. This factor is positive, but this factor is negative at x is equal to 2. Do you understand that? At x is equal to 2, this factor is positive, but this is negative, so the product is negative. What about x is equal to 0? At x is equal to 0, this is minus 1, this is minus 4. Again, the product will be, what's the product of minus 1 and minus 4? That will be positive. So basically, try some different values of x so that you get a little bit of idea. Okay, that's what's happening. And now you will be able to understand that. So basically, the procedure to solve this inequality goes like this. First of all, form a number line and mark the critical points. Form the number line and mark the critical points. What are critical points? Critical points are those points where each of the factor becomes 0, which we can directly observe, which is very easy to observe. We know that there are only two factors. This factor will become 0 at x is equal to 1. This factor will become 0 at x is equal to 1. And this factor will become 0 at x is equal to 4. These two are the critical points. Why this point is so much important? Because this is the point about which these factors will change their sign. Like if I talk about x minus 1, this particular factor, I know that about 1, this is going to change its sign. If x is greater than 1, this is positive. If x is less than 1, this becomes negative. So particularly this factor changes its nature, we can say, or its sign about which point? About x is equal to 1. And the second factor, this changes its nature or its sign about which point? About x is equal to 4. At x is equal to 4 exactly, they become 0. If x greater than 4, this factor is positive. If x less than 4, this factor is negative. Okay, so we got that idea. Now we want to comment about their overall sign, the sign of their product. Okay, the sign of their product. So basically, their product will be positive if both of them are positive or both of them are negative. If both of them are positive, then their product will be positive, or if both of them are negative, then their product will be positive. If one of them is positive, other one of them is negative, then their product will be negative. And that is the area we are looking for. We are looking for that area where one of them is positive, other one is negative. We are looking for their product less than 0. Okay. So see, we have 3 different regions. Okay. Number lines. See, these 2 points have divided number lines in 3 parts. One of the part is greater than 4. Another part is between 1 to 4. And the another part is less than 1. 3 parts they have divided. So now let's discuss about each of the part. What can we say about greater than 4? What can we say about greater than 4? If I put any value of x which is in the right of 4, am I getting a positive sign or a negative sign? If I put any value of x greater than 4, am I getting a positive sign of their product or negative sign of their product? So of course, I will be getting a positive sign, because if we talk about in the right of 4, both the factors are positive. The factor of x minus 1 is also positive. This factor is also positive if you put any value of x greater than 4. If you put 5, let's say, 5 minus 1 positive, 5 minus 4 positive. If you put 6, if you put 7, if you put 8, if you put 4.5. So in the right of 4, both the factors are positive. So definitely their product is going to be positive. Yeah. I'm going to give you rules. Okay, in the next slide I will show you the rules, that these are the rules we follow, so that you don't have to think so much every single time. Because you are learning it for the first time, I want you to learn in depth. I want you to learn and understand this thing. But later on I will give you some steps, that these are the steps you need to follow. But you will understand that steps very easily. You will see, yes, these steps are very, very logical. All of that steps are coming from this basics. So you need to understand this basics. So the basic is that in the right of 4, we have observed that both the factors are positive. So overall, we have put the positive sign. But in the left of 4, in this region between 1 to 4, what can we say? In this region, this factor, the factor of x minus 4 will give you a negative sign. Do you understand that? This factor of x minus 4 will give you a negative sign because x is less than 4. So this factor basically changes its sign. This factor is now negative, but this factor is still positive, right? The factor of x minus 1 is still positive. So this is negative, this is positive. Their product will be negative. So overall, their product will be negative in this region. Again, let me explain that. See what happened over here. What happened is that in the right of 4, both the factors were positive. In the right of 4, both the factors were positive. But when we, in the left of 4, when we came in the left of 4, what happened? Which factor changed its sign? The factor of x minus 4 changed its sign. The factor of x minus 1 is still positive because it is in the right of 1. If you put any value of x in the right of 1, this factor is still positive. But which factor changed its sign? The factor of x minus 4. And because this factor changed its sign, the sign changed from positive to negative. Now again, in the left of 1, what will happen? Now one more factor will change its sign. Which factor? This x minus 1 factor. This will change its sign again, right? In the left of 4, x minus 4 is negative. It has become negative. But now x minus 1 will also become negative. And now because both the factors are negative, their product will become positive. And that's what happening over here. You can put any value of x less than 1. You can put x as 0. What sign are you able to observe? If you put x is equal to 0, this is minus 1, this is minus 4, their product is positive. If you put x as minus 1, any value less than 1, you put any value less than 1, their product will be positive. Okay. So now what are we looking for? We are looking for less than 0. We are looking for those values of x where their product is negative. So now you can clearly observe on the number line that between 1 to 4, their product is negative. So the answer for the first part, what's the answer? The final answer is x belongs to open bracket 1 to open bracket 4. That will be your answer. Between 1 to 4, x should be greater than 1, less than 4. Then only their product will be less than 0. Okay. Suppose if they ask you this question. Okay. Let me delete this B part completely. Okay, we'll discuss that later. Let me ask you this question, that x minus 1 multiplied by x minus 4 greater than 0. Suppose if I ask you this question, then in this case, what will you comment? This time I'm looking for those values of x where their product is positive. So where their product is coming out to be positive, their product is positive in the right of 4 or in the left of 1. Or we can say that minus infinity to 1 and 4 to infinity. Okay. So here we can say that x belongs to minus infinity to 1 union 4 to infinity. That will be our answer for this part. Okay. See, in the left of 1. Okay, in the left of 1, we are going to write it as minus infinity to 1. Union in the right of 4. In the right of 4, we are going to write it open bracket 4 to infinity. Union means that we are taking both the intervals. We are taking this interval, we are also taking this interval. There is not just one interval, there is also another interval. We want to take both the intervals. So there is union. Union means or. That this portion or this portion, there will be a positive sign. Okay. Why are we not using close bracket? I hope you understand that there is we are not looking for equality. Okay, we are not looking equal to 0. If there is equality over here, then we can apply close bracket. That yes, we can include 1 now. We can include 1 if there's a equality over here. I hope you understand that. But if there is not an equality, there will be open bracket. If there's equality, there is close bracket. Okay. Now let me summarize the steps. Let me give you the steps that how do we deal with this. So the steps for that, make sure the RHS is 0 and the coefficient of x in all the factors is positive. This is the first step. Because as I told you, we use Wavy curve method only to comment that whether the product will be greater than 0 or less than 0. So that's what they are saying, that make sure that the right hand side is 0. The inequality is in terms of whether it is greater than 0 or less than 0. Basically, we are only commenting about the sign. So make sure one of the side is 0. Okay. And the coefficient of x in each of the factor is positive. Okay. Make sure that coefficient of x in each of the factor is positive. If it is not positive, we will make it positive. Okay. Don't worry about that. We will make it positive. Suppose there is a factor, like for an example, x minus 2 multiplied by 3 minus x greater than 0. Suppose this is the question I am asking you. Now here you can see that the coefficient of x is negative, right? In this factor, in the factor of 3 minus x, the coefficient of x is negative. Okay. So one of the side is 0, that's all right, but the coefficient of x is negative, so we will make it positive. How do I make it positive? Very easy, just take negative common from it. If you take negative common from it, this 3 minus x will become what? This 3 minus x will become x minus 3, correct? If you simply take negative common from it, 3 minus x will become x minus 3. Still there is no change in the inequality. Okay, there is minus, or you can say minus 1. So now if you divide by this minus 1 to the right hand side, now the inequality will change. If you divide by this minus 1 in the right hand side, now the inequality will change, and this inequality will become what? That x minus 2 multiplied by x minus 3 less than 0. Now this is our question. See, this was the original question given to us. We have changed this question into this one. This is x minus 2 into 3 minus x greater than 0. This is x minus 2 into x minus 3 less than 0. We have made the coefficient of x positive. So that's necessary. Okay, why are we saying? Okay, you will understand the logic behind it. That why are we making coefficient of x positive? Okay, because okay, now the step 1 is marking the critical point. So we are going to mark the critical point, put all the factors equal to 0 and mark the corresponding values of x in the real line. That's what we say about marking the critical point. So here if I want to solve it, I want to mark the critical points. Critical points are those points about which the sign is changing, and the sign is changing about 2 and 3. 2 and 3. These are the 2 points, these are the critical points. Okay. From the number line, mark the critical point. Okay. Now, the second step says that put positive on the extreme right. On the extreme right, in the right of 3, put positive. Put positive. Why put positive? Why are we not putting negative? How are you so sure that in the right of 3, there will be a positive sign? How are you so sure about that? Because of this first step. Okay. This step that we are making coefficient of x positive. If the coefficient of x is positive in each of the factor, then in the extreme right there will be a positive sign. That we can be sure about. Yes. If you put any value of x greater than 3, if you put the value of x greater than 3, this factor will be positive, this factor is also positive. So we don't need to worry, we don't need to check the sign. We can simply follow the steps that in the extreme right we can simply put positive sign. Okay. And then after each critical point and change the sign alternatively, moving towards left. Moving towards left, change the sign. Because about this 3, this x minus 3 factor will change its sign. Then about 2, this will also change its sign. So basically sign is changing after each critical point. After each stations, the sign is changing. So positive, negative, and then the sign will become positive again. Okay. Now what are we looking for? That you need to understand that we are looking for negative sign. We are looking for those values of x where their product is negative. So their product is negative between 2 to 3. So here the final answer will be x belongs to open bracket 2 to open bracket 3. That will be our final answer. So I hope you understood the steps. First of all, make 0 on one of these sides. Make the coefficient of x positive in each of the factors. In each of the factors, make the coefficient of x positive. How do we do that? Very easy. Some little bit of mathematical manipulation we need to use. So now this is our question. Now we are solving it, marking the critical point. On the extreme right, we can put positive. On the extreme right, we can simply put positive if the coefficient of x is positive. Okay, in each of the factors. Okay, now this question, let me take this question again, x minus 2 into 3 minus x. Let me take this question again. 3 minus x, what was the question? Greater than 0. What if I don't make the coefficient of x positive? Okay, suppose I am a very rebellious person. I am not making coefficient of x positive, that I will not be making coefficient of x positive. Now how do I solve this question? What will be the answer? Then also I can solve it. It's not that tough also. Again the same thing, the critical point. I know that this factor of x minus 2 changes its sign about 2. This factor of 3 minus x changes its sign about 3. Right? Now, in the extreme right, what do I put now? In the extreme right, what do I do? Now I need to check. Suppose if I take the value of x greater than 3, suppose if I take x as 5, let's say. So what happens at x is equal to 5? At x is equal to 5, this factor is positive, but this factor is negative, right? At x is equal to 5, this is positive, this is negative. So in the right of 3, this factor is positive, this factor is negative. Positive into negative. Overall, the sign will be negative over here. And then there will be a positive sign, and then there will be a negative sign. Basically, in the extreme right, we are getting a negative sign this time. Then positive, then negative. And what are we looking for? We are looking for positive. Greater than 0, right? Greater than 0. So what will be the answer? We can see that the positive sign is between 2 to 3. So x belongs to 2 to 3. Again, we are getting the same answer. Or what we can do, we can simply, take negative common and change the equation. Or what we can do, we can simply take negative common from it. We can write it as negative of x minus 2 into x minus 3 greater than 0. Then divide by this negative like we did, right? Less than 0. And then solve this one. To solve this one, now in the extreme right, again the same critical points 2 and 3. But in the extreme right, what are we marking now? In the extreme right, we are marking positive now. So that is why it is necessary to make coefficient of x positive. Because it will be easier basically. We can also solve it this way, but it will be easier. Now we know that in the extreme right, we don't even have to check. We don't even have to check. We know that in the extreme right, there will be a positive sign. Here we had to check that what will happen in the extreme right. And there came out negative sign in the extreme right. And then we are changing the sign as usual. But here we know, because coefficient of x is positive in each of the factors. So here we know that definitely there is going to be a positive sign in the extreme right. And we need to simply change the sign. That's it. And what are we looking for? We are looking for less than 0. What is less than 0? Between 2 to 3. Again the same answer. Okay. So I hope you understood these steps. You can read these steps again. Have a look at these steps. Read these steps again, and now we will be solving many questions on the Wavy curve method. Okay, now let's move ahead. Let's solve these inequality. The first one, very easy. Okay, quickly let's solve this one, guys. So there are two critical points, x minus 2, x minus 4. There are two factors, two critical points. The critical points are 2 and 4, right everyone? the 2 and the 4 are the critical point. Okay, we are not including 2 or we are not including 4. Okay, don't worry about that for now. Basically, what is the sign marking? Yes, coefficient of x is positive in both the factors. So in the extreme right, we are going to mark as positive, right? In the extreme right, there will be positive sign. In the extreme right, their product will be positive. Then there will be a negative. Then there will be positive. That's it. That's it. Positive, negative, positive. That's it. Okay. In the extreme right, positive. Why? Because the coefficient of x is positive in both the factors. So positive, negative, positive. What are we looking for? We are looking for greater than 0. We are looking for positive sign. So where do we see positive sign? We see positive sign in the right of 4 or in the left of 2. There is positive sign. There is a hollow circle on 2 and 4. Do you understand why? Because there is not any equality with 0. If there is equality, then we can use close. But if there is no equality, we can't use close. We are not including 2 and 4. I hope you understand the meaning of the question, right? See, we are not including 2 and 4. At x is equal to 2, the product will exactly become 0. It will not be greater than 0. It will exactly be equal to 0. And we don't have equal to 0 sign here. So we can't include 2 and 4. I hope you understand that, right? So we have x belonging to minus infinity to 2, open bracket, union, open bracket 4 to infinity. So this is our answer for the first question. Take now the second one. Second one, a quadratic is given. So first of all, we need to factorize it. Can we factorize this one? Yes, easily. There will be two factors. You will be breaking plus 2x 5x minus 3x. This is how you will break it. And there will be two factors, and those two factors will be x plus 5 multiplied by x minus 3. These are the two factors we are getting, right? X plus 5 into x minus 3 greater than 0. Now, what are the critical points? I hope you can do the factorization. That's not a big deal. Now, see, this factor changes its sign about 3. At x is equal to 3, this becomes 0. About 3, it changes its sign. This particular factor changes its sign about minus 5. At x is equal to minus 5, it becomes 0. And about minus 5, it changes its sign. So we have marked the critical points, which are minus 5 and 3. Minus 5 is coming from this factor. 3 is coming from this factor. Again, coefficient of x is positive on both the factors. So blindly, we can put positive in the extreme right. That is the usefulness of the first step, that make coefficient of x positive in each of the factors. It is already positive, so we don't have to do anything. Just simply put positive in the extreme right and then move towards left and change the sign, right? Positive, then we have negative. Okay, then we have negative, then we have positive again. Positive, negative, positive. What are we looking for? We are looking for greater than 0. We are looking for positive. So positive sign is this portion. Okay, less than minus 5, there will be a hollow circle on minus 5, and this is the positive portion from 3 to infinity. So minus infinity to minus 5, union 3 to infinity. There will be a open bracket at minus 5 and 3 because we don't have equality. Basically, we use close bracket when we have equality, as simple as that. X belongs to minus infinity to minus 5 open union open bracket 3 to infinity. That's our answer. Okay, now these two questions I am giving to you as a homework. You can easily solve these two ones. Okay, x square minus 5x plus 6 less than 0. Again, factorize this one. There will be two factors, x minus 2 multiplied by x minus 3 less than 0. X minus 2 into x minus 3. Their product will be less than 0 between 2 to 3. Correct? You can directly do this. There is 2, there is 3. Extreme right positive, then we have a negative sign, then we have a positive sign. So between 2 to 3, we can see a less than 0 sign. Answer is option B. Okay, simple. Now, if we have equality also, we don't need to worry about anything. Like in the first one, A part. We can make two factors, x square minus 8x plus 7. The two factors are x minus 7 and x minus 1. These are the two factors, right? X minus 7 into x minus 1. And we have greater than or equal to 0. So make number line, mark the critical points. The critical points are 1 and 7. In the extreme right, we put positive, then we have negative, then we have positive again. Very simple. Correct. What will be the answer? Greater than or equal to 0. So greater than or equal to 0 sign, we can see in this portion, basically positive sign. And there is equality, so we can include 1 now. There is equality, so we can include 7 now. Do you understand why are we including 1 and 7? Because they are also looking for those values of x where it becomes equal to 0. So it becomes equal to 0 at x is equal to 1 and at x is equal to 7. So we can include that. So basically in this question we will be using close bracket. So minus infinity to 1, x belongs to minus infinity to 1 close union close bracket 7 to infinity. That's our answer for this question. For the second part, for the B part, okay. This is the A part, everyone. Okay. Now, for the B part, x square plus 3x minus 40. 40 is the product of, okay, 5 and 8. 5 and 8, and the difference of 5 and 8 is 3 only. Okay, so their factors will be x plus 8 multiplied by x minus 5, right? These are the two factors. You can observe it. The second part, x square plus 3x minus 40, their factors will be x plus 8 into x minus 5. I hope you can factorize this. X square plus 3x minus 40. How do you factorize this? You can break this plus 3x into two parts. Plus 3x plus 8x minus 5x. That's what I'm doing. 8 multiplied by minus 5 minus 40. 8 minus 5 plus 3. Simple. And then we factorize it. We get to this part. Now after this it's very simple. There are two critical points. The critical point for this factor is 5. The critical point for this factor is minus 8. Okay, mark the numbers on the number line very carefully. Sometimes what does student do? They write 5 in the left of minus 8. That will be wrong. 5 will be in the right of minus 8, correct? So mark the critical points. In the extreme right, again we have a positive sign, then a negative, then a positive. What are we looking for? We are looking for less than or equal to 0. So less than or equal to 0, negative sign is in this portion. It is in this portion. So we are including, because there is equality. So our answer will be x belongs to close bracket minus 8 to close bracket 5. Close bracket minus 8 to close bracket 5. That's our answer for this. Now the third part, x square less than or equal to 4. So bring this 4 to the left hand side. We have x square minus 4 less than or equal to 0. There will be two factors. We can factorize x square minus 4. The two factors are x minus 2 into x plus 2. Okay. X minus 2 into x plus 2 less than or equal to 0. What are the critical points? The critical point is plus 2 and minus 2. That's where these factors are changing its sign. The critical points are minus 2 and plus 2. In the extreme right, we have again positive sign, then we have a negative sign, then we have a positive sign again. Okay, positive, negative, positive. That's all we are doing. Right? So what are we looking for? Less than or equal to 0. Less than or equal to 0 is in this portion. Negative sign we are looking for. So x belongs to minus 2 to 2. X belongs to close bracket minus 2 to close bracket 2. See, now observe the answer. See, observe the answer. Each of the answers satisfies this inequality. Suppose if I talk about minus 2 to 2, you can take any number in this interval of minus 2 to 2 and you can check that that number will satisfy this inequality. You can take minus 1, you can take 0, you can take 2 or minus 2. See, all of these numbers are satisfying this inequality. So you can also cross check whether our answer satisfies this inequality or not. Okay. Now let's move ahead. So I'm giving this question to all of you as a homework. Okay, let me do this for you guys. 2x square plus x minus 1. See, I'm going to break this x into two parts, 2x minus x, okay, to factorize this. So 2x square plus 2x minus x minus 1 greater than or equal to 0. This is the question we have, right? From these two portions, we can take 2x common. So 2x times x plus 1 minus 1 times x plus 1 greater than or equal to 0. From these two things, we are taking minus 1 common. So we have two factors. X plus 1 multiplied by 2x minus 1 greater than or equal to 0. Again, form a number line. Mark the critical points. The critical point for this factor is minus 1. This factor changes its sign about minus 1. This one changes its sign at which point? 2x minus 1 will become 0 at x is equal to 1 by 2. Right? 2x minus 1 becomes 0 at x is equal to 1 by 2. So this factor changes its sign about 1 by 2. Okay, got it? So you can just equate the factor to 0 and then check the critical point. So equate this factor to 0 and then check the critical point. So if you equate 2x minus 1 to 0, the critical point is 1 by 2. Okay, so these are the critical points. In the extreme right, positive, then negative, then positive. Okay, what are we looking for? We are looking for greater than or equal to 0. There's an equality. So this portion and this portion. Okay, so there will be close bracket because there's equality. So x belongs to minus infinity to minus 1, close union, close bracket 1 by 2 to infinity. Okay, that will be our answer, which is option A. Option A is our right answer for this question. Let's move ahead. Suppose these type of question, the part A. In the part A again, we are going to bring each term in the left hand side. Okay, bring each of the term to the same side. So here we have x square minus 2x plus 5. Bring this 3 plus x to the left side. We get minus 3 minus x, and there will be no change in the equality. It is still greater than 0. So we have x square minus 2x minus x. So x square minus 3x, 5 minus 3 will be plus 2, greater than 0. This is the equation, right? We brought each of the term to the same side. Then this is the final expression. You can factorize it. Their factor will be x minus 2 multiplied by x minus 1 greater than 0. Critical points are 1 and 2. Extreme right, positive, then negative, then positive. What are we looking for? We are looking for positive greater than 0. So in the right of 2, open bracket at 2. In the left of 1, there will be open bracket because there is no equality. So our answer will be x belongs to minus infinity to 1 union 2 to infinity. Open bracket at 1 and 2 both. I hope you remember that we don't use close bracket with infinity minus infinity. We use open bracket when we don't want to include. If there is equality, then we use close bracket. Okay. In case of equality, we use close bracket. Like in the second case, x plus 2 multiplied by x minus 3 less than or equal to x minus 3. Okay. So now let's bring each of the term, each of the factor to the same side. Okay, in the part B. So here we have x plus 2, then we have x minus 3, and then I'm bringing the factor of x minus 3. Bring this entire term to the left. So minus x minus 3 less than or equal to 0. Okay, this is what happens. You are bringing this x minus 3 factor to the left. So x minus 3 will become minus x minus 3, minus of this thing. And because we can see that the factor of x minus 3 is common in both of them, we can take it common. We can simply take it common. So if you take x minus 3 common, what do we get? We get x plus 2 here. If you take x minus 3 from it, x plus 2 will be remaining. If you take x minus 3 common, there will be 1 remaining in place of this. So x plus 2 minus 1, we have this now. So now we have made proper factors. We brought x minus 3 to the left and then taken x minus 3 common. These are the proper factors. So the factors are x minus 3 multiplied by x plus 1 less than or equal to 0. Okay, these are the factors. Now, what are the critical points? The critical points are -1 and 3. -1 and 3 are the critical points. Extreme right, we are going to put a positive sign, then a negative sign, then again a positive sign. Okay. So our answer will be x belongs to, because we are looking for less than or equal to 0, less than or equal to 0 will be this portion between -1 to 3. So x belongs to close bracket -1 to close bracket 3. Okay, that's our answer for the second part. I hope it's pretty easy for all of you. Try this question, giving this to you as a homework. Try this out. Okay. No. Let's do few more example. Okay. So basically, Wavy curve method can be used when we have more than 2 or more linear factor. When we have more linear factor, then also we can use Wavy curve method. Okay. Even if we have factors in the division, then also we can use Wavy curve method. Suppose if I give you a question like this, suppose x minus 2, x minus 3, then we have a factor of 2x minus 1 in the denominator. We have the factor of x plus 4 in the denominator, greater than or equal to 0. Suppose this is the question I am asking you. Okay. How are you going to solve this question? Very simple. First of all, again, the same case. Okay. Let me ask greater than 0, then I will ask greater than or equal to 0. Okay. So the first case is simple. Mark the critical point for each of the factors. See, you can already see that coefficient of x is positive in each of the factors, so we don't have to make positive. That step is clear. So simply you just move on to directly marking the critical point. If the coefficient of x is already positive, then simply mark the critical points. Okay, the factor of x minus 2 changes its sign about 2, right? The factor of x minus 3 changes its sign about 3. Okay. So let me mark 2 somewhere over here, then let me mark 3 somewhere over here, and then the factor of 2x minus 1. The factor of 2x minus 1 changes its sign about 1 by 2. And the factor of x plus 4 changes its sign about minus 4. These are the 4 critical points. There are 4 critical points. Why? Because there are 4 factors. We can see 4 factors, there will be 4 critical points. These are the 4 critical points. We have marked that on the number line. Critical points are those points where each of the factors changes its sign. Now, if we talk about extreme right, because the coefficient of x is positive in each one of them, again we can simply put which sign? Positive sign in the extreme right, correct? So positive in the extreme, then after each critical point, just keep changing the sign. So this positive will now become negative, then it will become positive, then it will become negative, then it will become positive. After each critical point, we are changing the sign. Why? Because at each critical point, one of the factor changes its sign. If any one of the factor changes its sign, the sign of the entire expression also changes. Okay. At each of the critical point, like suppose at 2, about 2, this factor will change its sign. About 3, this factor will change its sign. About 1 by 2, this factor will change its sign. So in the extreme right, we know that sign will be positive. Why? Because coefficient of x is positive. I hope now you are, understanding the logic behind each of these steps. Why do we make coefficient of x positive? Because now we can simply put positive in the extreme right. Okay. Then after each critical point, one of the factor changes its sign, and that changes the sign of the entire expression. Correct? Okay, that's it. Now, what are we looking for? We are looking for greater than 0. We are looking for positive sign. So where do we have positive sign? We have positive sign in the right of 3, but we can't include 3 because we don't have equality here. Okay. Then we have a positive sign between these factors, and then we have positive sign over here. We are not including any of the critical point, and of course you can't include 1 by 2 and minus 4, that you Can't include. Even if there is equality, you can't include those. Basically, remember this point, very important point. Don't include those values of x where denominator becomes 0. Never include that. Whether there is equality or not an equality, never include those points where the denominator becomes 0. Okay, so we are not including that. In fact, we are not including any of the critical point because we don't have equality with 0. So our final answer is minus infinity to minus 4, x belongs to minus infinity to minus 4, open, union 1 by 2 to 2, open, union 3 to infinity, open. Okay, now let me make a little bit of change in this question. Suppose if I put equality greater than or equal to 0, then what will be the change in the answer? What will be the change in the answer this time? If there is equality, everything else will be again the same. We are going to mark the critical point in the extreme right, positive, negative, positive, negative. All of these steps are still same. But now we need to include those points also where this entire expression becomes 0. And this expression will become 0 at x is equal to 2. At x is equal to 2, this factors become 0. And this will make this entire expression 0. At x is equal to 3. Right? So we now need to include the points 2 and 3. But we are not including the points 1 by 2 and minus 4. Because at 1 by 2 and minus 4, this denominator will become 0. So we are not including those points 1 by 2 and minus 4. Okay. So basically we are including 2 now. We are including 3 now. So again our final answer is x belongs to minus infinity to minus 4, open, union, open bracket 1 by 2 to close bracket 2, union, close bracket 3 to infinity. Okay, so we can include 2 and 3 now. That's the point. Okay, that's the point. So I'm giving you few questions. Suppose 2x plus 1 upon x times x minus 3 less than 0. How are you going to solve this question? Okay, let me solve this one for you, and then the rest of the question will be your homework question. So again in this question, mark the critical points. So there are 4 factors also this time, right? What are these 4 factors? X minus 2, its critical point will be 2. 2x plus 1, 2x plus 1 becomes 0 at minus 1 by 2. So its critical point will be minus 1 by 2. Then we have the factor of x. This changes its sign at 0 only. So its critical point is 0. Then we have factor of x minus 3. The factor of x minus 3, we have 0. And then the factor of x minus 3 changes its sign about 3. So these are the 4 critical points. We have marked that on the real number line. The factor of x minus 2 changes its sign about 2. 2x plus 1 about minus 1 by 2. The factor of x changes its sign about 0. The factor of x minus 3 changes its sign about 3. Okay, so these are the numbers. Again in the extreme right we can mark positive, then we have a negative, then we have a positive, then we have a negative, then we have a positive again. What are we looking for? Less than 0. Where are we seeing less than 0? Less than 0 is this portion, not including these critical points, and this portion. Okay, these are the points where we have the sign as less than 0. So x belongs to minus 1 by 2 to 0, union 2 to 3. That's our answer for this question. Okay. So guys, we have completed wavy curve method now. So this is it for this session today. In this session, we have learned about inequality. We have learned about different method, which is wavy curve method. Very amazing method, very interesting method. So I want you to practice more questions on this method, okay? And most of all, understand deeply what I have taught you, everything in this class, because the concept matters a lot. I have solved each of the question using concept. I have not used only the steps, okay? Steps are important to remember, but you need to understand the concept behind those steps. So I hope you have understood everything for this session. In tomorrow's session, we are going to start logarithm and we are going to be learning about logarithm in the next session. So see you in the next one. Till then, this is your maths teacher Kundan Makar signing off. Take care. Tada. Bye bye. Have a great day.